In the last class, we were discussing about rate determining step, and we had discussed that if a reaction is happening and there are two steps, two elementary steps, then the step which is slowest step is known as rate determining step. Means the reaction is governed and the reaction is happen only if the slow step is taking place. Okay, so next we will discuss about what is activation energy. So, activation energy is the minimum quantity of external energy required for conversion of reactant into product. Means what? Means अगर आपको किसी भी पर्टिकुलर रिएक्टेंट को प्रोडक्ट में चेंज करना है तो उसके लिए जो मिनिमम एक्सटर्नल एनर्जी देनी पड़ेगी उन रिएक्टेंट्स को, दैट इज नोन एज एक्टिवेशन एनर्जी. रेट ऑफ रिएक्शन इज डायरेक्टली इनवर्सली प्रोपोर्शनल टू एक्टिवेशन एनर्जी. इफ द एक्टिवेशन एनर्जी इज लो then the rate of reaction is high, and if the activation energy is high then rate of reaction is low. Okay, for increasing the rate of reaction the activation energy is always has to be less. Understood? Therefore the greater value of activation energy leads to lower rate of reaction and increase influence temperature change on rate constants. मीन्स अगर आप टेम्परेचर को बढ़ाते हो तो एक्टिवेशन एनर्जी डिक्रीज होती है, इसीलिए रेट ऑफ रिएक्शन बढ़ता है. ओके, so activation energy is the minimum energy that we supply from external source so that reactants can change into product, and the activation energy is inversely proportional to rate of reaction, and if we increase the temperature then activation energy decrease and the rate of reaction is increased. Okay, next is this particular graph will show energy versus reaction coordinate. Reaction coordinate means that how much reactions takes place. So activation energy is represented by EA. The energy of reactant molecule first have some amount of energy, and if we supply some amount of energy outsourced to the reactant then they form an activated complex. Okay, and that activated complex is further changes into product. So this is known as activation energy EA of forward reaction, and this is EA activation energy of reverse reaction if we have to change product into reactant again. All the reactants are always, or all the molecules in a solution or in a solid state, even though they are vibrating on their mean position in case of solid, and they are colliding in case of colliding with each other in case of liquid and gaseous molecules. So the molecule must have some energy due to collisions, and the energy plus some amount of energy we have to give to the reactants for change into product, and the energy with the reactant molecule first have is known as threshold energy, and the extra energy we supply plus threshold energy plus the energy we supply is given known as activation energy. Okay, next is Arrhenius equation. This is a very important equation as this particular equation gives us the relationship between temperature and rate of reaction. Temperature and rate of reaction. The Arrhenius equation is the most important equation because it gives us the relationship between temperature and rate of reaction. Up till now we know that rate of reaction increase by increasing the temperature, but how and which quantity, उसके लिए जो quantification था that is given by Arrhenius equation, that K is equal to A e raised to power minus EA by RT. So K is equal to E raised to power minus of EA by RT. This is your Arrhenius equation. In this equation, K is your rate constant, A is frequency factor or pre-exponential factor or constant. Okay, E is exponential, EA is activation energy, R is gas constant, T is temperature. If we take the natural logarithm of K, ln K is equal to ln A minus EA by 2.303 RT. Means एक्सपोनेंशियल और लॉगरिथम कट जाते हैं भाई, तो एल एन के इज इक्वल टू एल एन ए माइनस ई ए बाई आर टी. अगर आप इस पर्टिकुलर इक्वेशन को नेचुरल या फिर लॉगरिथम लेते हैं तो एल एन के इज इक्वल टू एल एन ए माइनस ई ए बाई 2.303 आर टी. ओके, नेक्स्ट इज Now, if we know that if we have to plot a graph, and if you plot a graph of y is equal to mx, this is given as y is equal to mx, and this is your plus c. So, equation of a straight line with slope. So, this particular thing will give you a equation of a straight line. So, this particular thing gives you a equation of a straight line with slope is equal to minus ea by r. And if ea is equal to 0, that means temperature goes to infinity. So, k is equal to a. E raised to power minus of ea by rt is your Boltzmann factor. For a chemical reaction, the rate of reaction get doubled for every 10-degree rise in temperature. This is because according to Arrhenius equation, k is equal to a e raised to power minus ea by rt. किसी भी केमिकल रिएक्शन में अगर आप 10 डिग्री राइज करते हैं टेम्परेचर को, तो उसका रेट ऑफ रिएक्शन जो है वो ऑलमोस्ट डबल हो जाता है भाई. Take log on both sides of this equation as we have discussed earlier. Ln k is equal to ln a minus ea by rt. Okay, so comparing the equation with the straight line equation, y is equal to mx plus c, where m is slope and y is intercept. So y is equal to ln k and x is equal to 1 by t. तो स्लोप किसके बराबर आ जाएगा अभी? माइनस ए बाई आर, और इंटरसेप्ट एल एन ए के बराबर. That is thing is shown in this particular graph. If we plot a graph of k versus 1 by t, ln k versus 1 by t, this is ln k versus 1 by t graph, then the graphs comes out to be like that. That means slope is equal to minus a by r and intercept is equal to natural logarithm of a. Okay, so next we will discuss about collision theory. Up till now we discussed that the rate of a reaction and temperature are interrelated by a equation which is known as Arrhenius equation, and which is equal to k is equal to a e raised to power minus ea by rt. Collision theory. According to this theory, the molecules, collision theory is put forward for understanding that how a chemical reaction happen, and why the chemical reactions, in a chemical reaction the particles are colliding with each other, why the chemical reaction takes place, why in some cases chemical reaction cannot take place. According to this theory, the molecules are colliding with each other with greater kinetic energy to bring about a chemical reaction. The molecules are always colliding with each other to give and to bring about a chemical reaction. The molecules of a reactant species collide through the space in a rectilinear motion. Means linear motion में the molecules जो हैं वो collide करते हैं एक दूसरे के साथ. A rate of chemical reaction is proportional to number of collision. जितने ज़्यादा collisions होंगे भाई उतना ही rate of reaction बढ़ेगा. इसीलिए जिस टाइम आप टेम्परेचर बढ़ाते हो तो आप number of collisions को increase कर देते हो. The molecules must be properly oriented. This is the most important thing. For a chemical reaction to happen, the molecules are always properly oriented. A rate of successful collision is directly proportional to fraction of successful collision into overall collision frequency. A rate of collision is directly proportional to fraction of successful collision into collision frequency. कितना collision हुआ है successfully और कितनी frequency है. रेट ऑफ कोलिजन उसके बराबर होता है नंबर ऑफ कोलिजन पर यूनिट टाइम और पर यूनिट वॉल्यूम. उसको आप क्या बोलते हो? कोलिजन फ्रीक्वेंसी. कोलिजन फ्रीक्वेंसी इज रिप्रेजेंटेड बाय जेड. सो द नंबर ऑफ कोलिजन्स पर सेकेंड पर यूनिट वॉल्यूम or number of collisions per unit time per unit volume in a chemical reaction is known as collision frequency. So if we have a equation, if we have a particular reactants A plus B is giving C plus T, then rate is equal to ZAB e raised to power minus A by RT. ZAB is your collision frequency, e raised to power minus A by RT is your activation energy. Okay, in many reactions the rate is equal to PZAB e raised to power minus A by RT. The P factor is included because the rate calculated from this formula is not correct, and if we include this particular factor which is steric factor, जो हमें बताता है कि पार्टिकल्स जिस टाइम कोलिजन कर रहे हैं उस टाइम वो पर्टिकुलरली अलाइंड है प्रॉपर ओरिएंटेशन में या नहीं। अगर वो प्रॉपर ओरिएंटेशन में है तो रिएक्शन होगी, अगर प्रॉपर ओरिएंटेशन में नहीं है तो रिएक्शन नहीं होगी। So steric factors gives us the proper orientation of molecules participating in a chemical reaction. Okay, as we can see here, effective collision can happen in this case, but in this case when the molecules are not properly oriented, the effective collision not happen. So these type of ineffective collision cannot form the product. Only the effective collision can form the product. So we have to add another factor, that is steric factor, for understanding or for calculation of rate of reaction. Okay, so we are done with the chapter, and next we will discuss about the NCERT problems of this particular chapter. Thank you so much.